Hi everyone. We are starting our kind of like tutorial series, and I have a little project I want to implement Copper on, and I want to bring you for a ride with me and kind of go through all the steps I'm going through to not only set up the hardware like we are looking today, but like set up Copper and making tasks and kind of like exploring the way we can make end-to-end a robot with Copper. And what I want to be able to do is to basically have Copper fly those Aerobatics Quad Copters. And so they are very powerful. They have like a 5-to-1, even like more 10-to-1 power to weight ratio. So it needs to be fast, very reactive. So that's a perfect application, especially with computer vision, right? The perfect application for Copper. And yeah, we want to make to build a demo for you guys, and so you can build your projects and we can push like a little bit Copper forward. But okay, when you want to put something on that platform, you need a camera, you need a compute on which you can deploy Copper. And so I tried a couple. I lost like few days with like so many like buggy hardware, very hard to work with and so on. And I ended up with this one that looks like it works. We'll see. So that's like a thing that's the format of basically a Raspberry Pi Zero. It's called actually a RATSA. You see the branding here, RATSA 03W. W is for the Wi-Fi. It's useful, so you can deploy remotely and so on your robot. So perfect. And what I advise you to do is to never ever try to diverge with the setup the manufacturers give you. I tried, I lost so much time. So basically, the distribution, this is the one they provide. The kernel, this is the one they provide. Yeah, it's going to be a shitty thing from 1993. You know what? If you change it, it will never work. You spend days and nights trying to port stuff. The BSP, like all the device trees and so on, you just use their tool to create them. If you try to hack your own thing, it won't work. Trust me, I tried on 3 different platforms. You touch it, you're up for like days and days to lost with this. So yeah, that's the thing. So that's what I did. I just have the platform down there, and I hooked up the camera like this. Of course, the documentation is wrong. So for example, this cable, you see, it's never like that usually. It's always the reinforced bit on the top of the PCB, but no, they basically routed their video output on the reverse, so it barely works because I don't think that connector is supposed to actually connect from the top, but yeah, it has something at the thing, so you can plug it in and force it in, and you can have it working. Yeah, those platforms they are bad, and the hardware is already bad. The software, we'll see. Actually, it's so quirky. Anyway. Let's get started. So that I'm logged right now with SSH on that little platform. If you look at it, yeah, that's an old kernel. We are at 6.10 or I don't know right now, right? And it's a specific kernel that has been patched by Rockchip, the manufacturer of the system on chip of that platform. So yeah, you see, take whatever they give you. You try to recreate that, you will fail. What we want to do first is set up this camera, right? Be able to watch a video out of this with Video for Linux, and then we'll be able to use the Video for Linux like component in Copper and hook that up and be able to actually make like a computer vision algorithm. And what I want to do there is to start with, right? Just be able to recognize an April tag in the image, get the pose of the aircraft relative to the April tag, and then try to have Copper piloting the drone and be sure that it stays stationary relative to the position of the tag, right? That's going to be the version 0 of like, yeah, this thing is able to fly, able to look around, find something, like even if it is like very like limited autonomy, right? Just like the minimum to be able to fly this thing, right? You always want to try simple, and then you'll build upon that, right? But you'll see already on the video side, it's going to be an adventure to actually make it working. So video phonics, usually it's mapped to those, you probably know, right? To those like character devices, we call that, I believe. And you see that there are plenty. Why do you have like 8 videos, video inputs, while you have one camera? We'll see what is going on behind the scene, right? And this one, I think it's just yeah, you see, it is just like a link towards like video 0, right? So they encourage you to actually, if you want to use the camera, read from video 0. But you know what? From my experience, video 0 doesn't work well. We'll explore why. So first, those platforms, those system on chip, right? They are very underpowered. So what they do is they do have like a bunch of like added silicon on their system on chip. For example, what we call like an ISP, an image signal processing, that basically can transform images where, right, we have primitives to transform from one format to another. You can compress, like you can see there, like actually the control for the compressor and the decompressor. You have a bunch of like little pieces of silicon like this, right? And how the kernel decided to map that, actually it works really well. I really like copper is working, right? That's also kind of a DAG. So let's see how it looks like. You can explore it with this command. You can ask basically, you know what? Give me the kind of the media stream for the media zero DAG it has, right? So you see that, for example, there is like a device here, right, which is an ISP, so Rockchip, ISP 0. And you'll see that you have like a device with like entities with numbers, right? And you have like pads there and sync and sources. If you are familiar with copper, you might understand like right away. But let me give you like a kind of a jot you like some drawing to explain you like quickly how it works. So imagine you have an entity, right? Entity 1. Follow what I'm saying because it's unreadable. And you have like pads. Here we have like pad 0, like pad 1. So that's a sync, and then you have a pad 2. That is a source, right? And you can have like other entities, like entity 6. And same deal, right? Like here, if you look at this one, you have like an input and output there, right? So again, pad 0 sync and pad 1 source. And then you see that yeah, it can be source for something else. So what happens is like those entities are kind of like bound together, right? You get, for example, a connector that gets from there and get, sorry, certainly not. Okay. Here you're basically like the physical camera here that is connected at the source, at the sync pad here, and then the source pad from here. Yeah, leave me alone. The source pad, you can connect it to a sync. That's exactly what is happening there. So if you look at this one, like this source, basically you have as input this format and as output this format, and that's connected to this one. Sorry. To the main path, right? And the main path could be this one, right? You see that, for example, it gets it from the ISP, and then this one, like this second entity, exposes it to /dev/video0. So you see that before this /dev/video0, you have all this shenanigan, right, that is happening, where you have like little components that are chained together that make transformations. So what does it do? If we look at it, the camera here is outputting in its physical format. So it's called a Bayard pattern. You can look it up. A Bayard, like a B-A-Y-E-R-E-D, right? And if we look at like the pixels, it's basically by group of 4 pixels, like this. And you see here that it is RGGB. So it's like this, RGGB. And that's basically the physical format of your CMOS sensor, this sensor here, right? Like that's really physically how, which color, which actual sensing like CMOS units are actually getting. It's made by filtering, right? Basically red is basically removing everything and only pass band the red frequencies, right? And G and so on. And like human eyes are more sensible to green. That's why you have like 2 greens. So you have like a better precision in greens. It's well known, like even like the old tapestries tapestries in France, right? They are like a lot of like green shades, because like, yeah, you can make actually a lot of like interesting like colors with that, and the eye is actually very adapted to that, probably because we were living in a green environment for a long time. Anyway, so those pixels, you have them back to back like this, right? G, G, B. So it's not natural, right? Like so first, it's not linear. You have 2G and so on. So usually this is not what you use as an input, right? When you are making some computer vision, you use I don't know, RGB or like simple video formats like this, right? So that's what it does first. Basically, it avoids to have us use this format as an input and have to do like some transformation in CPU to be able to use the video. And usually when you use video formats, like for example for encoders, you use YU/YV, for example. This is what it is using there, right? Like, or what it tries to use. We'll see. It's not necessarily true, but like those, like so that basically a chroma and contrast separation. That's usually used for like JPEG type of encoding, like MPEG and so on, right? Because you want to be able to encode the color on one side and the contrast on the other side, right? So that's a perfect format, and usually you use this format as an output on the ASP. That's what they are trying to do, and that connects to our video 0. But you'll see that it actually connects also the same input to video 1, the same input to video 2, to the same input to video 3, and so on, right? So actually not the same, but like various inputs to those ones, right? But at least like video 0, 1, 2 are the same, right? The same boop there, right? So probably like those, so you can see those kind of like virtual devices, kind of like some flexibility, right? So you can basically, for example, here, you can say that, yeah, you can output not only that format, but you can also replicate that format on another of those videos, and I believe that's what is happening there. So you can have like several outputs to debug your connected components, right? So you can probe basically what's happening. And sometimes it's useful to have like the original format and the transforms. For example, if you make a crop out of your video, it's cool to be able to have both inputs to be able to debug the crop, for example, because it's a lossy transformation. All right, so we've seen that. Now let's see if we can get like the video like we out of this one, right? The video 1. I think there is like a warning, and I think it crashed on me that you should not use video 0. Don't ask me why. This is one first quirk. You'll see like several ones, right? And we are waiting for some from YU/YV right there. So let's try the standard the standard capture, say hello to the camera. What I'm doing there is basically I do not specify any format. Say you give me whatever you have, set that to a file, and ask it for 100 frames. So we have a little bit of time to do like something meaningful in front of the camera, and I get it from video one, and you realize there that suddenly, oh wait, it's not YUYV it's actually used, it's NV12, right? Which is like a dual plan where you have a bunch of Ys and then a bunch of CBCR, right? Which are the components of the video. With that description, like 4 bits, 2 bits for the other one, or whatever, 4 bytes, 2 bytes, I think. And you see that basically that's not also the format it advertised in that thing, right? It's not that. Basically, and it's not that. Don't ask me why. We will check it out. So we'll try to reread that thing. So we just saved like a little format, video file. And let's get back to my own machine. So we'll try to decode this video. First, we need to copy it, right? So let's scp let's copper8.lan and that's temp if it works. Yeah, time slash video. Yeah, this one. And I copied that there. It will take time. So the file is actually pretty big. 677 megabytes for 10 frames, right? So when you are working with the raw frames, your bandwidth will be absolutely banged on, right? Like so that's why you need to be careful. Never copy videos and so on. All the work we made on Copper about buffers and so on, you can pass from task to task in Copper. It's because of that, right? You hit your especially on small platforms like this, you hit your memory bandwidth very quickly if you start to put those images in the Copper list, like basically copying that from one input to one output to one input from the task. You'll actually destroy your little machine that's gonna just be doing that, copying memory. That's it, with no resources for the rest. All right, so it copied that over Wi-Fi. So now let's use gstreamer, which is also again a kind of a graph thing you can use to display it. So let me walk you through this one if it can deselect it, right? So GST launch is basically the thing that can start one of those DAGs, and it gives like I give a file source with the location of the file, but then it cannot guess what you give it. Like basically, this file is a raw file where we just put like back-to-back buffers of video, right? There is no, I don't know, MP4 like a descriptive structure at the beginning telling the player what to play, right? So we need to tell it, right? So basically the width, we've seen that's basically that size. Actually, not really that size. And the height, that size there, right? I put NV12. I don't know why it suddenly became NV12, so I trust this output. And NV12 is not really neither like display friendly, right? Your screen, right, doesn't get that. Usually it's RGB. So if you want to use a video sync, which is a player for gstreamer, you just use video convert the element, and it will figure it out. Like, okay, what do you have on the left? What do you want on the right hand side? Okay, I will try to accommodate you as the best I can to display the video. So let's see if it works. It does. If I try to do that like a little bit quicker, you can see that I say just hello in the thing. So it has a weird format because like it's a lot of, like it's almost like a vertical format, like from a phone. And yeah, here you have it. We at least have exercised once our pipeline, and we'll see in the next episode how we can basically hook up the source of copper, the video for Linux source, to this thing, right? And try to see if we can negotiate like a better format than this one, and something that is workable. Maybe we can, or maybe actually it might be good, right? We could get like the gray side of the buffer, right? To straight have the gray transform from the NV12, and try to fit that and do like thresholding for those April tags too, so we can actually fly our little aircraft, right? So it can know where it is, right? So hopefully you like this, you learn something along the way, and hopefully I can see you in the next episode. That's going to be very, very vlogish, right? Like I don't have much time to actually edit those videos and so on, so it's going to be a little bit raw like that. But yeah, you can see my little mistakes and so on, so that might be a fun thing to discuss too. And if you have questions, feel free to leave comments below, and yeah, please subscribe to this channel so you can get a notification for the next one. Thank you.